Will now be recorded.
So my dear friends, let's start this session. In this session, we are going to learn how the packet is created. Okay. So for example, this is my laptop, and in this laptop, if I open up the website, famous website, which is google.com, and my dear friend, if I type the word news, then this news word goes to the Google server, and this is the Google server. And my dear friend, this news word goes to the Google server, and Google server will show me the news. But how this news word goes to the Google server, that's what we are going to understand in depth. So my dear friends, in the world of networking, you need an address. The same way in your real life, if you want to send a letter, what you need is you need a letter, and you will take a letter, you will put your theory here, and then this letter you will put in envelope. One second. Now my dear friend, thanks for the wait. So for example, if I want to send a letter, then I will take an envelope and I will put the letter in the envelope, and then I will have the from, that is my address, and then my dear friends, I will have the to, that is the friend's address. So I need my address, I need my friend's address, and then I can send the letter. So in real life, we need address for proper communication. The same way when we talk about networking, here we need IP address. And when we talk about IP address, we have the source IP, that is RIP. Source IP is RIP address. So our PC should have an IP address. And for example, what is my PC IP address? If I go here and if I type ncpa.cpl, and as of now, I do not have Wi-Fi, meaning I'm not connected via Wi-Fi. I'm connected via LAN. So LAN is also known as Ethernet. And if I double click on that and if I click on details, then I can see here my IP address. This is my IP address, 192.168.0.180. Now, if you are wondering how my PC got this IP address, it got via DHCP server. Now, what is DHCP server? I will explain you, and we would be making the router as a DHCP server also. So in upcoming session, we will see how the DHCP works and how to make a router or an L3 switch as a DHCP server. So as of now, these details are given to my PC from the DHCP server. So DHCP server, from the DHCP server, my PC has taken the IP and subnet mask and default gateway. All these things are there. We will understand them one by one slowly. As of now, my focus is on IP address. So my IP address is 192.168.0.180. So my dear friends, here if I put the source IP, this is my source IP, which is 192.168.0.180. So IP address my PC is having. The next thing, my dear friends, my PC need to create the packet. This packet, to create this packet, my PC need is the destination IP. So the data is there. In the data, the news word is there. This news word should go to Google, and The source IP, SIP, short form source IP is 192.168.192.168.0.180, and DIP is the destination IP. Destination IP address, my PC says I don't know the destination IP, because you have typed google.com and you have not typed the IP address of google.com. And to send the news word to Google, I need the destination IP of Google. I need the IP of Google, and you have typed a name. So my dear friends, that means the networking technology works on IP address. Without IP address, it cannot work. And we as a human being, we cannot remember IP address. I cannot remember IP of Google, Yahoo, Facebook. So there is someone who is there to solve this problem. And the problem is solved with the help of that someone, and that someone is known as the DNS server. Correct, you are right, my dear friend, it is DNS server. Now when we talk about DNS server, how a DNS server is created. For example, if I want to create a DNS server, I will take a server operating system. At big level, I will take a server operating system like 2022. And then, my dear friend, I will install the DNS role on this server. And after installing DNS role, are also known as DNS service, this server will get the power of DNS, meaning it will work like DNS server, and then it will have a name to IP table. Correct, you are right, Udit bhai, and it is a name to IP table. Now this name to IP table is like this. This is name, this is IP. And here you have few entries like www.google.com is having an IP like 5.5.5.5. www.yahoo.com is having an IP like 7.7.7. All the entries are there in the DNS server. And my dear friend, when you install the DNS service, a port related to that service open up on the server, and DNS port is port number 53. You have to memorize this. These are international port numbers. So I will repeat this. How a DNS server is created. You take a server operating system like 2022. Now you might be wondering, if you are not from server background, then what Microsoft has done, the way for your laptop you have Windows 10, Windows 11, and Windows 12 is also coming. So these are laptop operating systems, these are client operating system. The same way for server, to create a server you have server operating system like 2012, 2016, 2019, 2022. These are server operating system. So my dear friends, you have to take a server operating system, and after taking a server operating system like 2022, when you install the DNS service on this server, automatically port number 53 will open up on this server. That means every service has a fixed port number. So port number 53, not 53 ports, port number 53 will open up on this server. So every service has a fixed port number. Like DNS, when you install, it has port number 53. IIS, when you install, it has port number 80. Okay, so why you will install the DNS service? Because you want to make a server a DNS server. You want to perform the job of name to IP, then you have to install the DNS service. When you install the DNS service, automatically port 53 will open up on your server. And my dear friend, when you want to make your server as a web server. Okay, so that the website request will come. And then you have to install the IIS role and port 80 will open up on your server. The same way, there are different roles or service. These are known as like role or service in the world of Microsoft. Different roles or service are there. DSCP, and we can say file service, Active Directory service. Different things are there. But as of now, these two are important for our current discussion. Now, coming back here. So these are fixed international port numbers. Okay. On whatever server you install DNS service, port 53 will open. On whatever server you install IS service, port 80 will open. This is fixed. This is going to happen. And when you go for an interview, you might be asked, what is the port number of DNS? You have to tell 53. What is the port number of IS? You have to tell port 80. Now coming back here, my dear friends. So coming back on this. So you take a server like 2022 operating system and then you install the DNS service and then port 53 open up on this server, and this server has an IP address. For example, if I show you what my DNS is, my DNS is 8.8.8.8. Your DNS IP, if you check ncpa.cpl in your laptop, you will see the DNS IP can be different. Do not worry, IP address can change, your DNS server can be different, my DNS server can be different. We are understanding the working of DNS server. So I can have, for example, I can have a car of different model, you can have a car of different model, different company, but we are understanding the working of a car in general. The same way we are understanding the working of a DNS server in general. Okay, my IP is 8.8.8, your IP can be different. So here, if I put 8.8.8, this is the IP address of my DNS server. And when you install the DNS service, port 53 open up on this server. Now, my dear friends, what happens? This, when you go to the laptop and when you open up the Chrome browser, and when you type www.google.com and when you type the word news, your PC creates a packet. Data is news, source IP is your PC IP source, destination IP is the IP address of Google, but your PC says that you have not put the IP of Google, you have put a name. I want IP address. So your PC checks the LAN card, your LAN connection, ncpa.cpl, its LAN setting, and checks who is the DNS. Your PC knows that I need to ask the DNS server now. DNS server will help me for name to IP. So in my case, my DNS server is 8.8.8.8. So my PC says, okay, let me ask the DNS server, hey DNS server, give me the IP address of www.google.com. So what my PC does, my PC asks a question to the DNS server, and that is known as query, DNS query. So my PC creates a packet, and the packet looks like this. And in the packet we have the data, and in the data we have I want IP of www.google.com. I want IP address of www.google.com. And then, my dear friends, your source IP will be there, destination IP address will be there. What will be the source IP address? What do you think? What will be the source IP? Now, this packet cannot be created because this is a question mark. Where is the IP of Google? So your PC has to first create a DNS query packet. What do you think, my dear friends? what will be the source IP address? Anything that comes in your mind? Okay, host IP, Uttam Bhai says that PC IP, source IP. So the source IP address is 19 source IP meaning source SIP meaning source IP. This is your current when you open up the Chrome browser, your PC is the source. Correct. So RIP. So we can put here 192.168.0.180. Now, what will be the destination IP? What do you think? What will be the destination IP? What will be the destination IP? So the packet should go to the DNS server, correct? So the destination IP address will be the IP of DNS server, will be the IP of DNS server. Here the IP address of DNS server will be there, no? Here cannot be the IP of Google. If my PC says, if my PC is talking with me and my PC says, Zamir, if I knew the IP of Google, then why I will send the DNS query to the DNS server? If I knew the IP of Google, I will directly put here, no? I said, PC, you're right. So my PC says that I don't know the IP of Google. That's why I'm not able to create this packet. And that's why the news word I'm not able to send because I do not know the IP of Google. Then I have to ask the DNS server. When I have to ask the DNS server, I have to put the IP of DNS. So the destination IP address will be the IP of the DNS server. Getting the point? Because this DNS query will go to the DNS server. So that's why this IP address will be the IP address of DNS server. In your LAN card, whatever is the DNS server, that IP will be here. Is this clear, my dear friends? That's great. Now, the next thing is, now, apart from this, in your real life, when you are creating a letter, it has only two address, from and to. That's it. From and to. But in networking, there are multiple addresses. Source IP is one from, one to. The same way there is source port, and destination port, and there is source MAC and destination MAC. So my dear friends, here I will give you a bigger picture of this. Okay, there space is left, space is less. So here this is the DNS query packet. Data is I want IP of www.google.com, and the source IP is here and the destination IP is here and the source port is here and the destination port is here. And then my dear friend, the source MAC is here and the destination MAC is here. So there are total three from destination is two. So there are total three from and three to. So here when we talk about RPC, when this is the DNS query packet, so it will go from RPC, the source is 192.168.0.180 to the DNS server 8.8.8. Okay, this is what you have understood. This is done, complete. Now the next thing is, what is source port? SP. What is source port? Every packet has a source port. Every packet has a source port. SP and DP. Source port, source meaning your laptop, and a destination here meaning your DNS server. Okay, destination is your DNS server right now, because this packet is going to destination will change. Okay, when your DNS, when you are sending a DNS query, it will go to DNS server. When you get the IP of Google, then when you are sending the news word, then your destination will change to Google server, which we will see. Okay, so at this time, for this packet, the destination is your DNS server, and this is the IP of DNS server, and the DNS service is installed on the DNS server. So the DNS service is installed on the DNS server, and port 53 is open up on the DNS server, and the name to IP table is here, and all the website name and IP address are here. So source port, what is source port? Source, your PC will take any random port number, my dear friend. Source port is any random port number your PC will take from the range of 491522655535. Between this range, it will take any random port number. There is no need for you to worry. This is automatically taken by your PC. Your PC knows that I have to take this range because it is there, it is built in the PC's brain, in the PC's operating system, that I have to take any random port number from this range, which I will show you live. Packet I will capture and I will show you in front. So source port is any random port number. For example, it's take 49152, any random port number from this range 49152 to 65535. You cannot control that. Automatically for every packet your PC will take. Destination port is the port number of application or service where you are going, meaning your packet is going for DNS. Okay, this is a DNS query packet. So automatically your PC knows that this is a DNS query packet. Automatically it will put here port number 53. Destination port. Destination is here of port number 53. So destination IP is also set. Destination port is also set. Getting the point? Source IP is also set. 192.168.0.180 source IP. And source port, any random port number. Source IP is taken here, source port is here, destination IP is here, destination port is here. So destination port, your PC automatically it will put in the packet, which I will show you right away. In some time live we will capture a packet and I will show you that automatically your PC is putting destination port 53. Now the next is source MAC. The next part is source MAC. So this is completed. This is completed. Now the third from and to. Okay, now the third from and to. Now my dear friend, in the third from and to, it is source MAC and destination MAC. So as I said, so IP address and MAC address are required for communication. They are very important, and port numbers are also there. So MAC address is your PC has a MAC address which can be seen by the command ncpa.cpl. This is my laptop's MAC address, physical address, MAC address. So as an example, the MAC address is very big, so I cannot just put it down. So I will take an example. Imagine it's AAA. AAA is my MAC address because the MAC is very big. So imagine this is AAA. Okay. So this MAC address will be put here. In reality, the MAC address will be this one, FE0DAC5858E4. This will be there. Okay, this will be there. In my case, FE80, oh, FE not 80. Okay, let's put AA because the MAC is very big. So this MAC will be put here instead of AA. This MAC will be here. Now my dear friend, the destination MAC has a very big story. So you might be thinking the destination MAC will be of the DNS server. Now this is a story and which you will understand at the right time. At the right time, I will explain you. The destination MAC has a very big story, and that story will give you an idea what will be the destination MAC. So as of now, my dear friends, here we can put here, for example, in my case, in my scenario, my destination MAC is the MAC of router. Okay, my destination MAC is the MAC of router. It is not the MAC of my DNS server. It is the MAC of the router. So which I will explain you. It will take time for explanation, and then I will explain you about destination MAC, why the destination MAC of router was there in my case. How does it will take the source MAC? Now Mandar bhai, the way it takes the source IP, the same way it takes the source MAC. Source is meaning your own. When you are creating the packet, when your PC is creating the packet, it knows its source IP, it knows its MAC address. So there is no need for him to ask to anyone, right? It knows that my source IP is this, my source MAC is this, my source port is this, because that is there in the LAN card. If you do ncp.cpl and when you open a Ethernet, you will see that every LAN card has a fixed MAC address. So it knows that my MAC address is this, my IP address is this, and I have to just put a random source port number. Now, my dear friends, this packet is created. That means the packet has total 3 from and 3 to. One is source IP, destination IP, other is source port and destination port. Then the third is source MAC and destination MAC. Destination MAC can be the MAC of DNS server, but here in my case the MAC is of the router. Now why not the MAC of DNS server is there? Why the MAC of router is there? This need explanation, which I will explain you at the right time. Now coming back here, so my dear friends, this packet goes to the DNS server. Now if I go here, source port is any random port number. If I put here source port is any random port number, destination port is 53. Okay, source MAC is my MAC, my laptop MAC, and destination MAC is the MAC of router. So this packet goes via router, it goes to the DNS server. Okay, so slowly you will understand why the MAC of the router is put, because the packet has to go to the router, then the router will forward it to the DNS server. It will go like this. Now my dear friends, here for example the source port is, we have taken an example of, we will take the same thing. So we have taken an example of 49152. 49152 is my port number, source port. Now when this packet goes to the DNS server, when you receive a letter, you will see the to, for whom it is, you will see the from, okay, from where it has came. So the same way, this packet, this DNS server checks all the headers, okay, and it checks like, okay, my IP is there, my port number is there, okay, that's good. Now my dear friend, what it does, it gives the reply, to the DNS, to the PC, it gives the reply to the PC. So after getting this packet, the DNS server says, okay, what you want? You want IP of google.com? Okay, take the IP of google.com. The IP of google.com is 5.5.5.5. This is what the reply the DNS server gives to your PC. So my dear friends, I will show you this in action. Remember, you have joined a networking course. We are going to deep dive like this only in the entire course. How backend is working, how packet is created, how things are working in the backend. And there are a lot of people whom I know, they have done MCSE also from me, and now they have the passion to learn networking. So that's a good thing. In MCSE, normally everything is graphical. Networking is also very interesting, very simple. But here I have to draw multiple diagrams because I have to explain how things work in the backend, and I will show you by capturing the live packets. So you have an understanding that how in reality, if I'm telling you that the DNS packet is created like this, then how in reality it works. So for that, to show you, I will use a tool, and that is known as the Wireshark tool. So my dear friends, this Wireshark tool is a very popular tool. Wireshark, it's a free tool. After opening the Wireshark, it will ask me where you want to capture. So here I can see Ethernet because my laptop is connected on LAN. I'm not connected on Wi-Fi. I'm connected on LAN, and I can see that some activity is going on here, not on Wi-Fi. If you are connected on Wi-Fi, you will see here and you have to click on Wi-Fi. But if you are connected on LAN, then you will do the same thing the way I'm doing. As of now, there is no need for you to do anything on your system. Just see on the screen and try to understand the concept. Now, if I click on Ethernet, I can see here whatever packet is going out from my laptop and coming in, every packet is being captured here. I can see all the packet, and you can see here source IP, destination IP. So all the packets are being captured here. And if I want to capture only DNS related packets, to show you this, how your PC sends the DNS query, because when you go and type www.google.com, it is very fast in the backend. Your PC sends a DNS query. But if I want to show you the behavior, how it is been sent, then I can simulate that behavior by opening up CMD, and my dear friends, by typing the command nslookup. nslookup. nslookup is the command. Using this command, I can talk with the DNS server. When I type nslookup, that means my PC knows that now I'm going to talk with my DNS server, and this is my DNS server, which is there in my LAN card. The same IP address I will see here. Whatever is there in the LAN card, the same I will see here. Now, if I type here like www.flipkart.com, google.com, yahoo.com, for example, any website, or if I say www.google.com, because let's take first example of Google only. And if I want to see here, I have to filter with DNS. When I filter with the DNS, I can see all the DNS related query packet. Now my PC has sent some DNS packet in the backend. Okay. So which when I started the Wireshark capture, after that some DNS packet were sent by my PC in the backend, and they are being captured here. But just to show you live, if I type here, see here my dear friends carefully, if I type here www.google.com, my PC will create a DNS query packet. And if you see here, it has sent a DNS query packet and got the reply also. See here. So the reply is this IP address it has got, and this is IPv6, this is IPv4. What is IPv6? It's in, we will understand at the right time. There is a complete lecture on IP addressing, class A, B, C, D, E, subnetting, subnet mask, private IP, public IP, IPv4, IPv6. We will see that. But as of now, coming back on this point, so this packet I have captured, and this is the DNS query packet. Now, if you see this packet carefully, my dear friends, this, when I click on, you can see the details of this packet. And if I go back here, and if I see here, I've captured this packet, I will stop the capture. And here, this is my packet, and see here, this is the source IP address of my, this is the source IP. This is the destination IP. So when you do NS lookup and when you type www.google.com, your PC knows that you are talking with the DNS server. So your PC creates a DNS query packet, and the source IP is your IP and the destination IP is the IP of the DNS server. Source port is any random port number in the range of 491522655535. Any port number it will take. Destination port number is the port number of DNS. So this is your source IP, my dear friends. This is your source IP. This is your destination IP. This is your source port. This is your destination port. Now the next thing is, what is left? Source MAC and destination MAC. So this is your source MAC, my PC MAC. You can see F80D AC 585860E4. Okay. And if I show you as an example, I've taken AA, but F80D AC 5858E4, right? The same MAC is there. Okay, the same is there. So source MAC is my laptop's MAC, is my PC MAC. And destination MAC, as I said, destination MAC in my case, it is not the MAC of 8.8.8. It is the MAC of TP-Link router. Now, why? Because the packet has to go to the router, go via the router to the DNS server. There is an understanding for this. There is a reason for putting the destination MAC of router, and this is my TP-Link. I have a router of TP-Link at my office, and that is its MAC. Okay, so which we will understand. So as you can see, my dear friend, what we have understood here, source IP is source IP is 192.168.0.180. Destination IP address is 8.8.8. Source port is any random port number. Destination port number is 53. Source MAC is the MAC of your laptop. Destination MAC is the MAC of your router as of now. So have you understood this? When you are typing a name, your PC is creating a packet like this. I've just, by using nslookup command, I have simulated that packet, how that packet will look like. And the DNS query, if I open up the DNS query and the query, then the query is like this: I want IP of google.com. This is the DNS query. I want IP of google.com. Okay, I want IP of google.com. Getting the point, my dear friends? Have you understood this? Okay, that's great. Now you have to understand here one important point, how the response will come. Okay, now see the reply packet. We will see the reply packet. I will just note down this complete packet, okay, just to give you a better understanding. This is your PC and this is your DNS server. This is like 8.8.8 and DNS service is installed and port 53 is open up. And my dear friends, this is like the packet that goes from your PC. The data is, I want IP of www.google.com, and the source IP address and the destination IP address and the source port and the destination port and the source MAC and the destination MAC. Okay, all these things are here. And the source IP is 192.168.0.180 and the destination IP is 8.8.8 and the source port is any random port number. Okay, and the destination port is 53. But if I just come here, okay, so if I just come here and the source port is 62440, the source port is 62440 and the source MAC is my MAC AA and this is the router MAC, and the packet goes out to the router and via the router it goes to the DNS server. Now my dear friend, when the reply comes, okay, when the reply comes in the data, it is, okay, in the data it is the IP of Google. See, the reply is coming from DNS server to you and this is the response. The response is the Google IP address is, answer is the Google IP address is 142.250.142.100. That's what you see here. So the response comes that www.google.com has an IP address of 142. 251.42.100. This is the response that comes from the Google. Now the source IP address and destination IP address and source port and destination port and source MAC and destination MAC will become change. Okay, your source IP address is not the destination IP. The destination IP is not the source IP. 8.8.8 sending to 192.168.0.180. Your source port will become here, and your destination port, your source port and your 62440. Your source MAC will become here, and your router sending to A. It is like when you get a letter at your home and when you reply back, okay, when you get a letter from and to, okay, and when you reply back, your what will happen? Your to will become from, and your from will become to. Okay, so from your address it is coming to my address. When I reply back from my address, it will go to your address. So the to will become from and the from will become to. The same way here, source IP become destination IP, destination IP will become source IP, source port will come here, and it is like it is done crisscross. I will show you this. If I capture this packet and if I show you the response packet, see here, source IP is 8.8.8, destination IP is 192.168.0.180. Source port becomes 53 and the destination port is 62440. The reply comes like this. This is the reply coming from Google. Source MAC is the router MAC, TP-Link MAC, and destination MAC is my PC MAC, 5858E4. Okay, 5858E4. So my dear friends, the response is reverse. Getting the point? Are you understanding this? I'm showing you live how it is happening. Getting the point? It is like the same case of your letter. Your from will become to and to will become from. Your source IP will become destination IP. Destination IP will become source. Source port become destination. Destination port is given as source. Crisscross, and then response comes back. Okay. So now once you have got the reply, once you have got the reply, your PC says, that's great, I've got the reply from the DNS server. Now what I have to do is, I am ready for the news packet to be sent to the Google server. So it got the reply, and example, the reply is 142.251.42.100, but I am taking, for simplicity, I am taking the IP. Imagine the IP is 5.5.5.5. IP can be anything of Google. So just for simplicity, just to write it in a simple way, I say that in our example, we got the IP address, we got the reply from the DNS server, and that is 5.5.5.5. Okay, here the IP address is, this is the IP of Google. Imagine this is the IP of Google. So here our PC sent the DNS query packet, got the reply from the DNS server, and now it has put that in this packet. Now my dear friend, further what all things will be required for the packet to be completed? For the packet to be completed, my dear friends, further source port, destination port, source MAC, destination MAC, all these things will be required. So I need a space. So before going to that point, how the Google web server is created, So my dear friends, imagine Google took a Windows Server 2022 operating system and they install the IIS rule and port 80 open up on their server. Okay, port 80 is known as HTTP. When you access the website HTTP, it is port 80. But you might know that in today's world, any website which you access like kotak.com, any website, Kotak is one of my favorite bank. And I remember this bank in the time of demonetization. Everywhere, every bank, there was big line. This bank was having like only less number of people. It was like very in 20 people, 10 people, or I can say 15 people in the line. So one of the best bank, and I like this bank, very good service. So now my dear friend, if you go here, HTTP, all the websites are HTTPS, and there is a lock also. Why? Connection is secure. HTTP website you will not find. HTTP in terms of website, it is danger. Meaning whatever I am doing, if the website is HTTP, if I put my username and password here, if I go to net banking of Kotak, for example, Kotak net banking, and imagine if this is an HTTP website, and if I put my username and password here, in anyone can capture my packet and see the username and password. It is clear text. So that's why HTTP websites are not used. All the websites you will see, when you expand them, they are all HTTPS. Now who creates this HTTP? Who creates this HTTPS? You have to be in a relaxed state. You are not system administrator. That is the job of system admin. He will take a server, he will install the IS role, he will open up port 80, that is known as HTTP, and then he have to add a certificate. HTTPS need certificate. Okay, certificates are required. So connection is secure, certificate is valid, which I do all these things in the MCSE parts, CA's creation and all these things. It's a big discussion. But in short, this certificate is required. Being a core network engineer, if you are a core network engineer, you have to be just in a relaxed state. Okay, that system admin will do the job. So he will take the server, install the IS role, port 80 will open up, and then he will take a certificate from the CA, and he will bind the certificate to this to the website, and port 443 will open up, and then it will be ready for HTTPS. That means the transaction between your PC and your server is secure when your website is HTTPS. So my dear friends, imagine that our website of Google is HTTPS, and HTTP is, we disable this port. After enabling HTTPS, we disable HTTP port, because we cannot keep the insecure port and the secure port. We cannot say that access my website from HTTP also and HTTPS also. No. Okay, it is not possible. So when you are setting up a security, everyone has to go via the secure way. So that's why we just close this HTTP port. But when we install the IS rule, automatically this port open up, and then we have to add certificate, and then HTTPS port open up on the server, and then the communication between your PC and your server is secure, is safe. Now coming back here, so when we type HTTPS www.google.com, what happens? HTTPS port is 443, international port number. HTTP port is port 80, international port. DNS port is port 53, international port. You have to remember this. You have to by heart them. They are fixed. They are asked in a basic interview. They will be asked. Now, so coming back here, every packet has this headers. So the next is source IP and destination IP. The next is source port and destination port. And my dear friend, the next is source MAC and destination MAC. Now, source port. Remember, when source come, you have to think of your system. Source port is any random port number taken by your PC. Any random port number it will take. Okay, so I will repeat this news word is ready to go to the Google server. Source IP is your laptop IP, destination IP address is the Google IP. If your PC does not know the Google IP, it will ask the DNS server get the IP, which we have seen how the DNS query packet is created. And now the next thing is source port is any random port number, and destination port, what do you think, my dear friends? What will be the destination port? And the answer is correct. The destination port, when you are typing HTTPS, the destination port is 443, and if the website is HTTP, when you type HTTP, the destination port becomes 80. Okay, then the destination port is 80. So if someone is typing HTTP, then the destination port is taken as 80, And if by default when you type any website, automatically it takes HTTPS, so automatically it puts 443. So HTTPS is 443. Source MAC, my dear friend, is my laptop MAC, which is AAA. Destination MAC is not the MAC of the Google server, it will be MAC of router. But there is a very big story is going to come where I will explain you why it is the MAC of router, why here in this case it was the MAC of the router. Okay, there is a very interesting explanation for that. Now my dear friend, so this packet is ready to go. Source IP is my laptop IP, destination IP is of Google, source port is any random port number taken by my PC, destination port is the port number of the application. Because you are going to HTTPS application or HTTPS service, then 443 is the port number, source MAC is my laptop MAC, destination MAC is the MAC of router. Now the packet is ready to go, it will go to the Google server and the Google will give me the news. Okay. Now my dear friends, let's see whether I can show you this packet or not. So for example, if I want to show you this packet, I will start my packet capture. I've stopped my packet capture by clicking on the red button. Now I will start my packet capture and I will say continue without saving. Save also whatever capture I've done. If I want, I can save also. But as of now, I do not want it to save. So now I have started my packet capture. And now whatever is happening in my PC, so many things are happening, I don't even know. So all this packet, all these things are happening, something happens in the backend. So my dear friend, it is happening in the backend and all the packets are being captured. Now the thing is, if I want to capture the packet and if I open up an incognito window, and if I can capture, let's see, if I go to, can I capture, it is quite sometime it is tough to capture. So if I capture, if I want to go to google.com, www.google.com. So let's see whether I can capture this packets. TCP contains www.google.com, google.com. Okay, let's try to find using IP dot address, Google IP. This is the Google IP. Google IP changes frequently. Google is a big company. Their IP changes frequently. Okay. So finding Google is little bit tough. Let's go for something else. Like for example, Flipkart. Flipkart.com. If I went to Flipkart.com, and Flipkart has a fixed IP normally. So www.flipkart.com. What is the IP of Flipkart? This is the IP of Flipkart. Okay, let's capture all the packet going to this IP address. Tick, 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 tick. Now IP.address is a filter. Using this filter, I can capture all the packets going and coming from this particular IP address. Or if I want to say that I want to capture packet where the destination is this IP. So I can say IP.destination host. And these are Wireshark filter. There is a complete session on Wireshark filter. Now I have put here IP.dst underscore host space space to equivalent space and the IP. And if the filters are correct, now it becomes green. If there is a problem in the filter, for example, if I miss the T word, it will go into the red state. It says no, your filter is not proper. It should be HOST. You're just typing HOS. When I type T, when the proper filter is there, then only it works. Okay, now what I want is I want to filter all the packets. I want to capture all the packets which are going to Flipkart. Okay, so I can see this in the destination 192.168.0.180. And my dear friend, this is my source, this is my destination. Now I've, as an example, I've just captured one packet and you can see source IP is 192.168.0.180. Compare this, correct? Destination IP address is the IP of Google or Flipkart, whatever it is. Okay, so the destination IP address will be the IP of the website where I want to go. Okay, and source port is any random port number. Destination port is 443. Okay, and source MAC is my MAC 5858E4, and destination MAC is the MAC of router. So I was not able to capture the Google packet. Google IP changes frequently. There, Google is a big company, but Flipkart IP is fixed, so I was able to capture that. But concept is same. Imagine instead of Google, you went to Flipkart. Okay, your PC will send a DNS query, get the IP of Flipkart, and put it here. Okay, so source IP will be same. Destination IP will be the IP of Flipkart instead of Google. Source port will be any random port number. Destination port will be S443 because you are putting HTTPS. Getting the point, my dear friend? Are you understanding? So only thing is, instead of Google IP, here Flipkart IP will be there. That's it. Source port will be any random port number. Destination port will be 443 because you are typing HTTPS. Source MAC will be your MAC. Destination MAC will be router MAC. Concept will be as it is. And if you are going for flipkart.com, then here I want IP of flipkart.com. Only difference is here. Rest all the entire packet will be same. The DNS query packet, source IP, your IP, destination IP of DNS, source port, any random port number, destination port is the DNS port 53, source MAC, your MAC, destination MAC, router MAC, and only data will change. I want IP of flipkart.com. Simple. You will get the IP of Flipkart. You will put it here instead of Google IP, Flipkart IP. Rest all packet structure will be same if you are putting HTTPS. So my dear friends, IP address starting to number. Brother, you have to give me some idea. IP address starting to number. You can elaborate it. Now, if I want to capture, now right now I've captured the packets which are going from my laptop to Flipkart. But can I capture all the packets? So TCP contains, there is one way, TCP contains www.flipkart.com. Okay, I can capture flipkart.com. Okay, so here I can capture all the packets which are going from my PC to flipkart.com. There is a filter, TCP contains. Okay, all the transaction which is happening between my PC and Flipkart, I can capture all of them. Okay, I can see all of them, meaning in short, filters help you to find what you want. Okay, because when you start your capture, a lot of packets are being captured. So I want to filter it out and I want to see what I need. So that's why these filters are there. Now I've given you some filter as of now, like DNS filter. DNS filter will give you the DNS query packets. If you are performing some NS lookup and something like this, our DNS query packet, your PC is sending live, it can be captured from here. Okay, the next filter I've shown you is IP.destination host, where you can capture using this filter while putting the destination IP of Facebook, Yahoo, Google, whatever it is. You can capture all the packets which are going to that particular website. Okay, and one more thing is TCP contains entire communication happening between me and Flipkart, me and Yahoo, and me and Google. Then I can say TCP contains www dot for example, I have right now went to the Flipkart website. I can see flipkart.com, Flipkart, and www. Instead of removing www, directly I can see all the communication. Now my dear friends, so coming back here, so I hope you have understood this entire thing. I hope you had a good idea of this. Now just give me a moment. Okay, okay, so Yes, that's why Jadip bhai LMS is there. LMS is the best way for revision. Now, my dear friend, now we will come for OSI model. Remember, my dear friends, one request to everyone is you have joined a course. Now, a course, you have to put your efforts. A request from my side. First of all, you should not miss any live lecture. The next thing is you have to put in efforts. The more effort you put starting at some topic, you might find it tough. But when you revise it multiple times, now you will find it easy. Simple rule of success. It happens. So when you revise multiple times, slowly, you will find it easy. And when you revise multiple times, you will become expert in that. So from easy to expert, you will go. The same thing which was tough for you for some time before. Now coming back to the point of OSI model. So my dear friends, OSI model is very important model, and OSI model, you might have heard about this multiple times. Open system interconnection. So OSI model was created by international organization which is known as ISO, International Organization for Standardization. This organization creates standard. They avoid monopoly. They do not want monopoly to happen. Monopoly meaning I am the only one in the market. I say that has to be followed. The way in your SIM card, there are different like Tata is there, Airtel is there, and Reliance is there, Jio is there. So different providers are there. So because of this, monopoly is not there, and everyone is trying to take the customers, and they are giving offers to everyone. The same way Amazon is there, Flipkart is there, different e-commerce website is there. Imagine only Amazon is there, only one Amazon is there. Now if only one provider is there, they can charge you anything. Example, they will say we will take delivery charge 200 rupees. There is no other e-commerce website, only one e-commerce website is there. So that is known as monopoly. So monopoly is danger. So in olden days, what happened, if you had a switch of, for example, Cisco, then in your company the next switch you have to take Cisco only. If you take a switch from a HP company, then it will not work. Meaning they cannot communicate with each other, because the way they were communicating was their own standard they have developed for communication. So Cisco switch was communicating in a different way, only Cisco switch can understand. HP switch was communicating in a way which only HP switch was able to understand. The same way IBM Microsoft laptops, desktops were communicating the way they can understand. HP laptops are, sorry, HP was not there. For example, IBM laptops was, our desktops were communicating only they can understand. Now we are talking about like 1980s, something like this. I was not born, you were not born. Might be some of you might have born on 1980. So in those days, Microsoft and IBM, those companies, they were having their own standard of talking. So you cannot have a Microsoft and an IBM PC. You cannot have a Cisco and an HP switch. Communication will not happen. I'm just giving an idea. So then this company, this international organization for standardization came into picture. They said, no, we want a standard. Everyone will speak the same language. All network devices, whether whichever company they belong to, their concept of networking will be same. And they created a model which everyone has to follow, and that is known as OSI model. And my dear friend, now when everyone follows the same model, that means they are speaking the same language, and communication will happen irrespective of whatever vendor they are. They will follow the same language, they will follow the same structure, and that structure consists of 7 layers, and that is known as the 7 layers of OSI model. So because of OSI model, interconnection between different vendor is possible. There is a standard which is created, and you can have different you can have an Apple laptop right now, you can have an IBM laptop, HP laptop, you can have a Cisco switch or other company switches in your office connected to each other. Why? Because they all understand the same language, they follow the same OSI model. So my dear friends, when we talk about OSI model, there are total 7 layers in OSI model. So just give me a moment and let me open up the OSI model. Okay, so OSI model, when sending the data, when sending, comma, the data goes from layer 7 to layer 1. And while receiving, the data goes from layer 1 to layer 7. Now that means when you are sending something, the data will go from layer 7 to layer 1. Layer 1 is physical layer, and at receiving it will be received from the physical layer, and then it will go to the layer 7. So my dear friends, sending and receiving, let's see this. So these are the total 7 layers, 7 layers of OSI model. Okay, and it is look like this: application, presentation, session, transport, network, data link, physical. So each layer has some job, and there are few layers which are not there in, there is no responsibility for them in the world of internet, in the world of networking which we are learning. They do not have any responsibility. So let's see them. So as of now, there are total 7 layers: physical, data link, network, transport, session, presentation, and application. And my dear friend, layer 1 is, this is layer 1, physical layer. Layer 2 is data link, layer 3 is network, layer 4 is transport, layer 5 is session, layer 6 is presentation, layer 7 is application. Now imagine you are, we will take the same example which we have learned before. You have a PC. Your PC has an IP address of 192.168.0.180, and the MAC address is of AAA. This is your PC MAC address. Remember, these two addresses are required for communication, without which the communication cannot happen. And you type https www.google.com. When you type www.google.com, automatically the https is added. Now my dear friends, now what happens when you type the word news? What happens? Your PC tries to create the packet, but it is not having the IP address of google.com. So what it will do, it will create a DNS query packet. Okay, so now for example, let's imagine, for example, imagine that your PC is having the IP address of google.com. So it is having the IP of google.com. So there is no need for DNS, meaning, for example, if it has asked the DNS, it got the IP, and once again you open up the Google browser, once again it will not query the DNS once again. Okay, it has got the IP address, it will take the same IP address which is known as the DNS cache. So it is there in the DNS, in the PC's DNS cache, it is there in the cache which has a timer of 1 hour. So within 1 hour, if you try to Google multiple times, your PC will not ask the DNS query again and again. Meaning, you are, for the first time when you open up https and google.com, your PC will ask the DNS server get the IP. The IP that it got, it will keep it for 1 hour, and that is known as the DNS time to live. Your PC will store that in its cache, in the local cache of the DNS. So next time when you ping within that 1 hour, or next time when you open up the website of Google within that 1 hour, it will not ask the DNS. It says, okay, I've got the answer from the DNS. This is the IP, 5.5.5 is the IP. Correct. It is the temporary cache which is known as the DNS cache, which you can see via the command. There is a command, if you want, you can see, that is known as the ipconfig display DNS. This is the command you have to open up, and you can see this cache display DNS. and you can see your PC cache. It's a temporary cache. ipconfig space / display DNS. Now coming back here, my dear friend, so I want to explain you this OSI layer. So for simplicity, I'm saying that okay, your PC has asked the DNS server and got the IP, and now when you open up the Chrome browser again within that 1 hour, your PC will not ask the DNS server. It says I have the IP. It will directly create the packet. Now how that packet is created? Okay, so let's try to understand this. So my dear friend, you are at the application layer. Which layer? Application layer. So you are at HTTPS. When you type HTTPS, this is an application. HTTPS is an application, DNS is an application. So HTTPS is noted down 443. So my dear friends, when you are typing HTTPS, that is an application and that is been noted down. So at application layer, meaning remember, Chrome browser is not an application. Sometimes people feel that Chrome browser is an application, Mozilla browser is an application, Internet Explorer is an application. They are browsers. They will help you to access the website. They are not application. HTTPS is an application. When you type HTTPS, HTTP, DNS, they are the application. So in this case, you want to go to the this website. Okay, and this one is I will note down this all again. It's all gone. So L1, L2, L3, L4, layer 4, layer 5, layer 6, and layer 7. So when we type here https www.google.com, and when we type the word news, so my dear friends, for example, your PC had the IP, it will first note down the application. So you are, when you type http, that means you are at the https, this is the application and the port number is 443. So it notes down the application that you are at, the application is https. Then there is no presentation layer and session layer in internet. There is no job of presentation and session. Presentation layer is used for encrypting the data. There is no by default encryption. Session layer is used for making the session. There is no session layer. So I've given the theory, but in our internet world, there is no job of presentation and session. Okay, so if I just go here, and OSI model says that in presentation layer you have this thing. Okay, I will just give you an idea. So in session layer, this layer establish, manages, terminate session. Every layer has a job, okay, between sender and receiver. So this layer creates some session. So there is no session work in session layer. In session layer, in internet model, OSI model says that in session layer you have to do, but the one who people who created internet, they said okay, there is no job for us in the session layer. So there is no need for us to create any session. So session layer is empty. Now, the next thing is presentation layer. In presentation layer, OSI model says that the data has to be encrypted and compressed, and then it will be sent. But in internet, there is no by default encryption and compression. So the internet which we are using, the network which we are using, there is no presentation layer. So there is no responsibility of presentation layer. They are empty, meaning there is no job for session layer and there is no job for the presentation layer. Okay, so directly your news word will come to the transport layer. Getting the point, my dear friends? Directly your news word will come to the transport layer. And now you have to understand important thing. In banking, they use session layer. That's the reason session get expired after a particular session. No, that is your browser session. That is your application. Meaning your banking application has a session timeout that is set at the application level, not at the OSI model level. So when you create a web server, you have a option that if no one is browsing your website, then you can time it out as a part of safety. So now my dear friends, so that setting is done at the web server level. Now coming back here, so in this case, what you have to understand, what happens in the transport layer. So my dear friend, in the transport layer, your data The news word will be here. And the transport layer adds the source port and destination port. The headers are added at the proper layer. Transport layer add source port and destination port. Network layer add source IP and destination IP. Data link layer add source MAC and destination MAC. And then your data is converted in the form of current. If you are connected via cable, or if you are connected via Wi-Fi, then Wi-Fi signal and sent out. So my dear friend, application layer notes down the application like HTTPS, DNS, HTTP, whatever application you are using. When you go to the browser, you type HTTP, you type a website, automatically it takes HTTPS. So that is noted down. That means you are at the application layer. Then presentation and session layer is not there. Your data will not be encrypted and compressed by default, and there is no session layer, session creation. Session creation part is given to transport layer, which I will explain you in TCP. So presentation layer and session layer is empty. Then the data comes to the transport layer. Now transport layer is a very powerful layer. It has multiple jobs. And my dear friend, transport layer says I will add source port and destination port. So transport layer adds source port and destination port to your packet. So we have learned that source port is there, destination port is there, source IP is there, destination IP is there, source MAC is there, destination MAC is there. But at which layer they are added, they are important. It is not directly it has been added. Your packet goes from layer 7 to layer 1, and at transport layer the source port, the transport layer adds the source port. It takes the any random port number and add it. And the destination port is, because you are typing HTTPS, destination port will be 443. The same thing we have learned, only now we are understanding that how it will happen layer wise, how the headers will be added. The job of the OSI model is to add the headers, that's it, not the data. Data is given by you. You are uploading some file, downloading some file, you are going to you're going to Google typing news, you are going to Amazon typing t-shirts. Data is given by you, data is managed by you. These OSI models, they are just adding the headers. So at which layer what header is added? At transport layer, source port and destination port is added. Source port is any random port number and destination port is the port number of application. You are going to the HTTPS application, port number 443 is added. Automatically it has been done. These things are happening, we are just understanding them. Now my dear friend, the same packet goes down. As I said, sending will be from top to bottom, from 7 to 4. Okay, sending will be from 7 to 4. So the same packet will go, as it is, it will go here. The news will be there, the source port will be there, the destination port will be there. And now my dear friends, here in the network layer, two important things will be added. And network layer will add what? Network layer will add source IP address and destination IP address, SIP and DIP. Source IP address is 192.168.0.180, and destination IP address is the IP of Google 5.5.5.5. Imagine your PC knows the IP of Google directly, it will put. Okay, so source IP address is your laptop IP, your PC IP, and destination IP is the IP of Google. So this packet is created. Now my dear friend, the same packet as it is, it goes to the data link layer, same as it is, same news, same source port and destination port, same IP address, source IP 192.168.0.180, destination IP is 5.5.5, same, the packet is coming as it is. Now my dear friend, here source MAC and destination MAC is added. Source MAC is your PC MAC, destination MAC is the router MAC. So getting the point, my dear friend, transport layer adds source port, destination port. Network layer adds source IP, destination IP. Data link layer adds source MAC, destination MAC. So this is known as L4 header. This is known as L3 header. This is known as L2 header because they are added at data link layer. They are added at network layer. They are added at transport layer. Are you understanding, my dear friend? The same packet creation which we have learned before, we are understanding at what layer which header is added. So transport layer source port, destination port is added. Network layer in the same packet goes as it is to the network layer. The network layer adds source IP, destination IP. The same packet goes as it is to the data link layer. The data link layer adds source MAC and destination MAC. Then your packet goes to the physical layer. Physical layer consists of all those things which you can touch and feel, like the cable going out from your laptop and Wi-Fi signal which you can feel. If it is physical cable, you can touch it. Okay, so at least you can touch and feel them. So that is, if you have a physical cable, it will be converted, your data will be converted in the form of current, or if you have a Wi-Fi connectivity, your data will be converted in the form of wireless signal and they will send out. And when they will go to the receiver, at the receiver side, for example, when it goes to the Google server, the Google server, it will go to the physical layer first, then it will go to the data link layer. The data link layer will read the data link layer header, source MAC and destination MAC. The network layer will read the network header, source IP, destination IP. Transport layer will read the transport header, source port, destination port. Then presentation and session is not there, it will go to the application, and the application layer, it will show you the news word. Okay, so it will hit the web application and it will show you the news word. You will see the news, meaning it will read the news word and it will show you the news. So my dear friends, sending side it goes from 7 to 1, receiving side it goes from bottom to top from 1 to 7. So when the packet is received, first the L2 headers will be read, then the L3 will be read, then the L4 headers will be read by the transport layer, L2 will be read by the data link layer, L3 will be read by the network layer, L4 headers will be read by the transport layer, and then presentation and session is not there. It will hit the application will read the word news and it will show you the news. So my dear friend, this is the importance of OSI model. Every company, every manufacturer of network device, Cisco or any Microsoft laptop or HP laptop, all of them follows the same structure. So if you open a Wireshark and if you run in your Wireshark in your laptop belongs to, for example, Dell or other company, you will see the same thing: source IP, source port, source IP, destination IP, source MAC, destination MAC. Data can be anything, but headers will be same because they all follow the OSI model and they all are on a standard. Now my dear friend, here I will also explain you the DNS part, the DNS query part. Okay, so here I have explained you this part, how this part will go, this packet will go. Now I will explain you how this packet will go. Okay, as per the OSI model. Very simple. If I go here and for example, just give me a moment. Now for example, my PC, in my PC, I have typed, for example, I have typed www. We can say, for example, amazon.com. Okay, any example I can take. And when I type www.amazon.com and I want to type the word t-shirts, now what will happen? My PC first will say, okay, do I have the IP of Amazon? No, I do not have the IP of Amazon. So what my PC will do, it cannot send the t-shirts word to Amazon, so it will not create this packet. It will create a DNS packet. Getting the point? My PC does not know the IP of Amazon, so it will not directly create the t-shirt packet for Amazon. It will first create the DNS query packet. So the application is DNS, presentation and session is not there. Transport layer will create the packet, and that is the data. The data is I want IP of www.amazon.com. Whatever it is, you go www.google.com, yahoo.com, facebook.com. Your PC does not know the IP of the website. It will do the same thing. It will create a DNS query packet and it will put here in the data, I want IP of Yahoo, Facebook, Google, whatever it is. Source port and destination port are added by transport layer. Source port any random port number, destination port is 53 because it's DNS. Port 53 will be there. Packet goes to the network layer. Packet goes as it is. This packet goes as it is here, and here it is added what? Network layer adds source IP, and my dear friends, it adds what? It adds destination IP. Now source IP address is 192.168.0.180 and destination IP address will be 8.8.8.8. Am I right? Same packet, I want IP of amazon.com. Source port is any random port number, destination port is 53. In that, source IP and destination IP is added. The same packet comes to the data link layer. Same packet is coming as it is, or with all the details. It is coming as it is. And my dear friend, here same I want IP of amazon.com, source port any random port number, destination port 53, source IP 192.168.0.180, destination IP is the IP of DNS. Now what yours data link layer adds, it adds the source MAC and the destination MAC. Source MAC is the PC MAC, destination MAC is the router MAC, and now this is how the packet goes out. Okay, finally it comes to the physical layer, converted to current or Wi-Fi signal and sent it out. Then it goes to the DNS server. The DNS server goes from the layer 1, it goes to the layer 2. The layer 2 reads this layer, then the layer 3 reads this, and the layer 4 reads this, and then it goes to the DNS application. It reads your data, I want IP of google.com. It gives you the reply packet. In the reply you get the IP of Google or Amazon or Facebook or Yahoo, whatever the query is. So my dear friend, this is how the DNS query packet is created. So have you understood this? Okay, that's great, that's good. Now further we have to understand a very important thing, and that is about transport layer. And in any interview you go, you will be asked about transport layer. Very common interview question. Even OSI model is also a very common interview question. If you're going for a fresher network related opening, you have to just memorize this what I have given. This is theory. Theory is there. The physical layer is responsible for connecting devices. Whatever you see in physical in nature, like hub. Now hub you do not understand right now. Do not worry. Hub is a physical device. LAN cable, fiber cable, SFP module, RJ45 connector, LC connector, LAN adapter, wireless adapter. All this comes under physical layer. Data link layer you cannot see. Network layer you cannot see. Transport layer, session layer, presentation layer, they are all software layers. They are inside, we cannot see. Now can we get this PDF? Yes, my dear friends, this PDF is there in LMS. So I hope you all have access to LMS. From LMS you can get all this PDF. Now the source, the data link layer is layer 2. So I have given like at the start, if I remember, I went for an interview in 2009 and he asked me, tell me about OSI model. I started OSI model, the functionality, why do we need an OSI model? You have to just, these are theories. Theory you have to memorize. When you go for an interview, obviously you have to memorize the theory. Okay, and then you have to memorize this also. Data link layer, the source MAC and destination MAC is added, and switch works at data link layer, which I will explain you. Switch works at the data link layer, meaning there is an L2 switch. By default the 2960 switch which we have seen in the previous example is an L2 switch. That switch can only understand MAC address, which I will explain you. Switch, in the working of switch, we will understand switch works at data link layer, meaning switch can understand only MAC. Now in network layer, the source IP and destination IP's address is added at this layer. Router works at network layer. Router or L3 switch. Router or L3 switch works at network layer. L3 switch. So router can read a source IP and destination IP. L3 switch can read a source IP and destination IP, which I will explain you in the working of router. This I will explain you the meaning of switch works at data link layer. What is the meaning of this? We will understand in the working of switch. When we say router works at network layer, what is the meaning of this? That means router can read source IP and destination IP. But after reading, what router has to do? What decisions routers has to take, that we will understand. Or when we say that switch works at data link layer, that means switch can read source MAC and destination MAC. But after reading source MAC and destination MAC, what a switch can do, that we will understand in the working of switch. Manageable switch, all switch are manageable. But in companies we use manageable switch only, unmanaged switch we do not use. If the company is having unmanaged switch, then there is no job of network engineer. So when all switches that we use in production, they are manageable switch, meaning you can connect them, you can configure them, you can uh, do multiple type of configuration in them, which we will learn slowly we will learn. Now sometimes I avoid taking big words, even though I know that I just take configuration. Now what configuration? So that configuration will come at the right time. So coming back here, my dear friends, so transport layer is a layer 4. Now transport layer is a very big layer and very important layer. Transport layer says that I am adding source port and destination port. The way data link layer adds source MAC and destination MAC, the way network layer adds source IP and destination IP, I add source port and destination port. But apart from that, I do other job also. I am responsible that your data should be error free and successful communication should happen. Meaning whatever data you are sending, you are uploading some drive in Google document in Google Drive, you are typing the news word, that news word should properly go to the Google server. I am responsible for that. Now, how it takes this responsibility and what is segmentation and marking, that's what we are going to understand. So the first job you have understood about transport layer is, my dear friend, about it adds source port and destination port. But there are other responsibilities of transport layer. Okay, let's understand other responsibility. And now come the topic where we are going to understand what is TCP and what is UDP. Now this is a favorite interview question. In any interview you might go, you might be asked what is TCP and what is UDP. So my dear friends, coming on this topic of TCP and UDP, so TCP is transmission control protocol and UDP is user datagram protocol. Now you might be wondering, uh, sometimes some full form has no sense. Some full form they have no sense. Transmission control protocol and user datagram protocol. So my dear friends, when you go for an interview, always remember the interviewer is not interested in full form. That's why I also do not remember most of the full forms, but but my recommendation is that do not start the interview with full form. But if the interviewer is asking you, okay, tell me the full form of TCP, you explain the interviewer everything about TCP and UDP. But finally the interviewer says, no, I will pass you only when you tell full form because I want full form. There are some interviewers, they are interested in full form. Okay, so you have to tell him. If he's asking, do you know the full form of TCP? If someone asks you, normally in interviews people do not ask because the technical interviewer, he is sound enough and he will not be interested in full forms. But if someone is asking, because interview can be taken by anyone. I have given interview one of the time when I've given an interview in 2010, or I can say no, 2012. So in 2012, I've given an interview. I did my technical round, telephonic round was there. I went for a face-to-face round. There was a senior program manager who was sitting. I was sitting in front of him. It was a big boardroom, and he just opened up the PDF like interview question, whatever it was, and he had a fixed set of questions in front of him, and I know that he is asking the questions from the laptop. So he read the question, okay, and then he look at the question, then he asked me, look at the question, he asked me, because actually he was a non-technical person. He was, then when I got the job in that company, I came to know that he is just a program manager, and he's only meant for communication, and he's completely non-technical. He has done some degree from some big university, and he has got this job. But my dear friend, he stayed in that company only for a few years because he was non-technical. The below people, the managers, they used to report him the issue, sir, this is the issue, and he was not able to communicate that issue. So your communication is good, you are a very good speaker, and on mail also you are very good, but if you are non-technical, it is impossible for you to stay with that profile for a long time. Someone will take you over. So coming back here, so that's what the same thing happened, and the package at that moment he was getting was a very good package. I came to know all these things later. Now, so coming back here, so transport layer has the job of TCP and UDP. Now transport layer has to do this. Now let's see how it works. First of all, we have to understand what is TCP and what is UDP. So my dear friends, the one who creates the application, I'm not the one, you are not the one, but someone has created the application or the service, we say. So that application is the someone has created the DNS application, that you will take a server, install the DNS server, port 53 will open, and then it will behave like name to IP. PC can query and it will give the answer. There was a need of some service like this, so someone created the DNS service, DNS application. When he or she has created the DNS application, I don't know who has created, they went to INA is an international authority, and they have taken a port number that my application will have port number 53 fix. No one else can take this port. The same way, when there was a need of a web server, so someone created the IIS service, that you take a server, install the IIS service, and your server will become like a web server. You can host a website on that. So someone has created this service. So that someone has taken port 80. By default, in olden days, it was HTTP. Security issue was not there. Then because of security issue came HTTPS 443 came. Now, my dear friend, here important point is that someone has also decided whether his application will be TCP or UDP. Port number he has taken from INA. He has to take the authority from INA. INA is an international authority which manages the IP addresses and all these things. Networking authority. So from there, they have taken this port number. But whether their application is TCP in nature or UDP in nature, they have decided. The one who creates the application, he has decided that my application DNS is UDP, and HTTP and HTTPS, they are TCP. So what is UDP and why? What is TCP and why he has decided for DNS UDP and for HTTP and HTTPS TCP? My dear friend, TCP meaning reliability, and UDP is like little bit unreliable, but UDP is faster, TCP is little bit slower. Now in TCP, when your application is TCP, it is guarantee delivery of data. There is a guarantee that your data is delivered, guarantee delivery of data. So in HTTP and HTTPS, we wanted guarantee delivery of data. I'm typing news words should go to Google. There should not be like N is going, E is going, and W is not going, and S is going. I do not want, I want when I type news, only news should go. I should not want that this should go to Google. I want a guarantee. If this word goes to Google, Google will show me this result. So I want a guaranteed delivery of data. So the one who created the application, he says, no, web server, this is very critical. Not a single thing should be lost. So my application will be TCP. Reliable, it is little bit slow, but that's fine. But there is a guaranteed delivery of data. And the one who created the DNS application, he said that DNS is getting thousand of queries, lakhs of people are asking the DNS server. I want fast response. So they created DNS as UDP. UDP is faster, but it is unreliable. If you ask a query, and if that query is not received properly, DNS will not respond to you. There is no mechanism. UDP is unreliable, which I will explain you. What is the meaning of unreliable? What is the meaning of guaranteed delivery of data? I will explain you how it works. So my dear friends, so DNS was created, the one who created the DNS application, he has decided that my application will be UDP. Now we are going to understand how TCP and UDP works. Getting the point? Now, my dear friends, let's see how this works. So coming back on this point, on this point, on this point, what is TCP? In TCP, what happens? How TCP says that I guarantee delivery of data. When my application is TCP, then what my PC does, okay, my PC does a three-way handshake. My PC does a three-way handshake. That is, for example, I will take the example once again. So now we have to understand TCP and UDP, and slowly we are at the ending of this session. Are you here, my dear friends? In today's session, in the first session, in this session, normally in the entire course, I take a lot of theory, because without this theory, practical cannot happen. From the next lecture, which is going to come, till the last lecture, complete practical you have to do along with me. Just give me a moment. So in these two lectures, the first lecture 1 and this lecture, I have to speak a lot because there is zero practical in this case, and I cannot do anything because networking has practical, but it has theory. Because as a network engineer, if your theoretical concepts are clear, then only you can do the practical. If theory is not clear, practical cannot be done. Networking is not like Microsoft, next. You can close your eyes, next button is grayed out. Finally, just take your mouse to the right side, you will see the install button. Blindly also anyone can do. It's simple. Networking, you have to run a command, you have to configure a router, you have to configure a switch, you have to first think in your mind what I'm going to do. Remember, one Facebook outage has happened recently, I think 6 months back. That was because of routing issue. Such a big company, things can happen. A routing loop happened and the entire network was down, and there was a very big outage. You can Google out Facebook outage due to routing issue. Now coming back here, so network is very important, and network is outages are very critical. And being a network engineer, you are also important, because you are handling important things, critical things, which can bring down the entire company and declare an holiday also. So coming back here, so my dear friends, so what is TCP all about? So when I go here, we will take the example back of www.https and www.google.com. And when I type the word news here, step number 1, my PC will send a DNS query packet, and it will ask the DNS server. And imagine my PC sent the DNS query and asked the DNS, and it got the reply. Now the next thing is, it got the IP. Now my PC has to send this news word, my dear friend, to the Google server, www.google.com. Google server it has to send. So what it will say, HTTPS, it's a TCP based application, fix. So what happens, your PC follows the application OSI model application presentation session. Okay, so application layer is not application layer is there, HTTPS is there, session and presentation is not there. Transport layer is important. Transport layer will not directly send the news word, my dear friend. It will not directly send the news word and add the source port and destination port. So source port, any random port number and destination port 443. No, directly it will not send. Transport layer says, wait, what is the application? Application is TCP. I cannot directly send the news word. First, I have to create a three-way handshake. I have to make a three-way handshake. First, I will check whether the server is live or not. If it is not live, then why should I send the news word? So that's why it's like a handshake. When you call someone, you say hello. It's an handshake. Then the other person says hello. It's a two-way handshake. So you say hello, the other person says hello, then your conversation start. Okay, that means you are able to, you are confident, he is able to hear you, you are able to hear him. The same way here, before sending the data, my PC will create a three-way handshake, and that is, it will send a sync packet, a dummy packet. It will send, it will stop this. Remember, it will do the DNS, all this part is done, but now the news word, before sending to the Google server, because HTTPS is a TCP based application, it will first send a sync packet, a dummy packet, sync packet, and then it will get the, if it is up, it will get the reply sync act, that okay, I acknowledge your sync. If there is no reply, the news word will not be sent. Why should I send the news word when the server is down? Okay, if it gets the sync act, so this said hi, okay, example sync, and the Google says, okay, hi, I received your hi. Okay, so it says, okay, hi, I received your hi message. Now my PC will send an acknowledgement back. My PC will send an acknowledgement back. It will say that, okay, Google, I have received your hi message. So it is like sync, act, and act. Now this is known as three-way handshake, meaning your PC send a sync message to Google. Google replied back, okay, that your message is received. That means your PC is confident that you are able to connect to Google. So this is known as, till here it is two-way handshake. But one more handshake is added so that the Google server knows that, okay, Google's acknowledgement is received by you. Getting the point? So then once again you send a hi message to the Google, because Google has acknowledged you, but Google is waiting. Is my acknowledgement received by you? Is my acknowledgement received by you? You acknowledge it back. Okay, Google, your acknowledgement is received by me. So that is known as three-way handshake. So my dear friend, if I go here, sync, act, and act, and that can be captured also sometimes in Wireshark. If we can capture also, and I will show you that three-way handshake Wireshark capture, three-way handshake Wireshark capture. So someone has done the capture. You can see here three-way handshake. This PC, this is for example Google server. Example, any server it is. Sync packet goes. Then from Google server, reply coming from to my PC, sync act, and from my PC once again acknowledgement going to Google server, act. So sync, act, and act. Getting the point? Now once this three-way handshake is done, then only my PC will send the news word. Getting the point, my dear friend? This happen only in TCP, huh? Not in UDP. If the application is UDP like DNS, there is no three-way handshake. For the DNS query packet, when your PC is sending the DNS query packet, it will not perform three-way handshake with the DNS server. Why? Because DNS application is UDP. Directly it will send. Okay, so three-way handshake is only for TCP based application like HTTP and HTTPS, and that is important because we want to confirm that the person with whom we are contacting is live there or not. Okay, so connectivity handshake should be there. Now the next thing is transport layer. So what you have learned so far about transport layer? Transport layer adds source port and destination port. Correct. Transport layer checks whether the application is TCP or UDP. And if the application is TCP, it will perform three-way handshake. If the application is UDP like DNS, it will not perform three-way handshake. If there is the DNS query packet coming, it will not perform three-way handshake. Have you understood this, my dear friend? Okay. Now going ahead, one more job is of transport layer. Whom will check three handshake process? Whom will check? Whom will check meaning automatically it is done whenever you go to any website like Facebook, Yahoo, Google. Before sending your data, for example, you type amazon.com, https amazon.com, https is TCP na, and you type t-shirt, your t-shirt word will not directly go to Amazon. First your PC will send a three-way handshake, will send an acknowledgement. Hi Amazon server, are you there? Amazon will reply, yes I am there. Then it will say, okay, yes I am also there, let's start the data transfer. Getting the point? Which layer with transport layer does this job? Meaning from transport layer, the dummy packet is created and sent out. So the sync is also a packet, and it has the source port, destination port, source IP, destination IP, source MAC, destination MAC. So the sync packet is created and sent out from your PC. Okay, so when I say the sync, so sync is also a packet and it goes out from your PC, and the sync packet will look like this. It will also have the headers. Okay, source IP will be there, destination IP address of example Google is there, source IP of your laptop, source port, any random port number, destination port is HTTP, HTTPS, whatever you have put, HTTPS 443, source MAC, your MAC, destination MAC of router, all these things will be there. So sync packet will be created the same way your normal packet is created. Getting the point, my dear friend? So from transport layer, it will create the sync packet, source port, destination port will be added in the sync packet, source IP, destination IP will be added by the network layer, and source MAC and destination MAC will be added by the data link layer. The sync packet will go out and the sync acknowledgement will come, then the acknowledgement packet will go, and then your news word will go. Getting the point, my dear friends? So sync is also a packet. So first transport send a dummy packet, correct? Perfect, you are right. First it send a dummy packet known as sync, then it sends the actual packet. And in the dummy packet also source port, destination port will be there, source IP, destination IP will be there, source MAC, destination MAC will be there. What will be the data part contained in the dummy packet? No, there is nothing in that. That is like, this is an acknowledgement packet, please acknowledge it. Something like this it will be there. Getting the point? There is nothing there in that. It's like, okay, please, this is an acknowledgement packet. Only few things related to acknowledgement packet structure it will be there. Data will not be there. So my dear friends, coming back on this point, now the next thing is, if TCP is secure, then why do UDP is there? UDP is created for, especially it is created for DNS, because DNS servers, thousands of queries come to DNS server. So every time three-way handshake is been done, the DNS server will get frustrated. Because thousands of queries are come to offload that, especially for the DNS, the UDP is there. Okay, so TCP is used, TCP is secure, so your HTTP, HTTPS applications are all critical application, your WhatsApp and all these applications, they are all TCP. Okay, mostly for UDP you can use like DNS, you can use for UDP, because DNS has to give fast response, fast response to everyone. Now my dear friend, coming back on this point, so the next thing which transport layer does, okay, the next thing which transport layer does is segmentation and marking. And you might be wondering, what is segmentation and marking? So segment meaning it creates small packets and mark them. My dear friend, imagine you are at your PC, you are uploading 100 MB file to Google Drive, will it go directly or it will go slowly? It will go slowly, right? Multiple packets will be created and then it will go. So your data 100 MB will be divided into multiple packets and then it will go. Now who is dividing that into multiple packet? That is transport layer. Transport layer says my job is segmentation and marking. As a simple example, I will take the news word. We are at the ending of this session. I appreciate your patience. Time is up. But I appreciate your patience. So if I type here HTTPS and www.google.com, and when we type the word news, so what happens at each layer? The application layer is HTTPS and presentation and session layer is not there. Transport layer is a big layer. Transport layer says that, okay, I first do, because it is it's TCP application, I first do a three-way handshake. It is done. The dummy sync packets are gone. The reply come, okay, the three-way handshake is done. Now the time to send the actual data. Now, my dear friend, the actual data is not transferred like that only. It divided into packets, meaning it segment them and it mark them. Now with this example, imagine in real life this news is a small word, it will go in one packet. But just to give an idea, you are uploading some thousands of 100 of MB document and downloading something, it will not come at once. It is divided into small packets. So that job of segmenting the packet, dividing the packet and marking them is done by transport layer. Let's see. If I go here, imagine this is the data, the n will be there. So what it will do, first the transport layer will divide my packet, the news word into like 1 of 4, 2 of 4, 3 of 4, 4 of 4. So there are 4 words, so it will divide that you are 1 of n, you are 1 of 4, e you are 2 of 4, w you are 3 of 4, s you are 4 of 4. Okay, so the way on Twitter also you see now 1 of 1, 1 of 2, 2 of 2 messages, it goes like this. The same way your data is marked, is segmented, it has been marked. Now the first packet goes, data n is there, and it will have the source port and the destination port. Okay, then in the network layer and the data link layer, it will come, and then in the network layer what will be added, the network layer will add in the it will add the source IP and the destination IP. And my dear friend, when this packet come to the data link layer, it will add the source MAC and the destination MAC. Okay, and now this packet is ready to go. It goes out to the Google server. First packet goes to the Google server. The Google server says n received, 1 of 1 is received, and it will send an acknowledgement that I have received one packet. So that is TCP. In TCP there is an acknowledgement. Each and every packet which is sent is acknowledged. Not in real life, not one packet will be sent, thousands of packets will be sent at once and one acknowledgement will come. Now the next is, it will send the same way, n is received, the same way my dear friend e will go, e is received, 1 of 4, 2 of 4 is received, it will send an acknowledgement. The same way my dear friend w will go out, and imagine w went out but there was an internet connection and w packet was dropped because of some network flap. So what will happen, your Google server will say I have not received 3 of 4, 3 of 4 I have not received. Okay, for example, your PC says I have sent w is not received, and now your PC is sending the last packet, that is the S packet. The S packet is received by your server, 4 of 4 is received, but your Google server says I have received 1 of 4, 2 of 4, I have received 4 of 4, where is 3 of 4? Retransmit me 3 of 4, I want 3 of 4. So then your PC will retransmit, and then it will get 3 of 4. So your PC will retransmit and w, and then it will get 3 of 4, and then the complete news word is completed, new S. Okay, so this is known as error free and successful communication. Transport layer helps in error free and successful communication. If the packet is lost in between, it can happen, it is internet. So TCP says I guarantee delivery of data, I acknowledge the packet, if acknowledgement is not received I will retransmit. Getting the point? It can retransmit by its own, or it can retransmit by the server, the Google server asking it. Okay, so in short, we say that in TCP there is guaranteed delivery of data. Why? Because every packet is been acknowledged. Now when we talk about UDP, my dear friend, UDP is completely opposite of TCP. No three-way handshake, no guarantee, no acknowledgement, I am faster. That's why UDP is used for DNS. In DNS only one packet goes, one query packet goes. If you see here DNS, and if I go here, and a lot of packet has been captured, that's why it is taking the file too long. Okay, I will just continue without saving, and if I say www.google.com, you can see this DNS query packet are just one packet it goes, the reply comes. Okay, and you can see that it is UDP, clearly it is written UDP user, it's a UDP packet. If I go here and type like flipkart.com, who usually use UDP? DNS is a perfect example of UDP. No three-way handshake, nothing, no acknowledgement. You do not see also any acknowledgement here. Do you see in the, if I've captured the packet, no acknowledgement is also there, nothing is there. Okay, only source IP, destination IP, source port, destination port, DNS, and all these things are there. Okay, UDP is a perfect, DNS is a perfect example of UDP. You just ask, one single packet is going, reply is coming. So that's why DNS was created in UDP style, because we want fast response. So if there is no reliability also, that's fine. If my PC asks the DNS server is not responding, my PC will again ask DNS server, hey DNS server, give me the response. Again it will create the packet and send. Okay, so DNS is perfect for UDP. Now I will show you one thing, and that is, my dear friend, uh, that is TCP contains Flipkart. And can I show you the Flipkart website? If I refresh, okay, I refresh and something is happening. So here HTTPS is a TCP based application. Do you see clearly it is written transmission control protocol, right? So it is HTTPS, correct? It's a TCP based application. So here it is TCP. Okay, now do you see a sequence, acknowledgement, all these things are there. So every packet is acknowledged. If you compare this with the UDP packet, there is no concept of acknowledgement. Do you see this? There is nothing like this. But here in TCP you have the concept of acknowledgement. Getting the point? Focus on acknowledgement. There is a concept of acknowledgement here. So each and every packet which has been sent is been acknowledgement. So TCP says I guarantee delivery of data. Now my dear friends, I hope you have a very good understanding about TCP and UDP, and there are some port numbers, applications, and I've given their port numbers also, internationally used application and their port numbers also, and I've given an ID also here. And this is like just theory, you have to just read them. And this packet take data by each word or how. So Mandar bhai, your Mandar bhai, you can say that what is the maximum size of the packet, meaning what can be the, when we are segmenting the packet, when I'm transferring and uploading an 100 MB file, what if thousands of packets are created, then what is the maximum size of the packet? How the packet is created by the transport layer? Is there any size, or randomly it is creating anything? So that we will understand with an example which is known as MTU. So the transport layer segments the packet, but that segment has a size. That segment is packet, is interchangeable word. Okay, normally generally we use the word packet. So your transport layer creates multiple packets, but that packet has a size, and that is known as MTU, which we are going to see in the upcoming session. So my dear friends, that's it for this session. Okay, and for the next session you have to install the packet tracer. and there is a video in LMS. You can watch the video, and when for the next lecture when you come, that is your packet tracer software should be installed. Okay, so I'm ending this session.